Okay, so we're going to test this claim. So the claim is mu is greater than 1210. So first of all, we're writing down the null and alternative hypothesis. So excuse me, HO and HA. So the claim is mu is greater than 1210. So first of all, which claim is that? Is that HO or HA? Anyone?
HA.
Yeah, it's HA. And then we can go back and fill in HO. That's going to be the opposite of greater than, and the opposite of greater than is less than or equal to 1210. So there you go. So first thing is those, that's your, let me see. Okay. So those are your claims. So next, calculate the standardized test statistic. In other words, what's the Z for that? Okay. So the problem is given in kind of a structured way, but really the way I presented it in the lecture videos is really the sort of proper way to do a hypothesis test. And I'm going to emphasize doing it that way rather than answering their questions one by one. So first we've got the hypotheses, and we've also got the stuff that's given, which it's given in just sigma equals blah, blah, blah. It's given already in notation as a formula, so we don't need to copy that over. But what we do need to do is describe the distribution. So let's describe the distribution. So first of all, what's the shape? So the shape, it says assume the population is normally distributed. So we know that the shape is normal. And the mean, well, the claimed mean is 1210. So we don't know if that's the actual mean, but it's the claimed mean, so that's what we're going to use. Or I should say it's the claimed mean that we're going to compare our statistic with. That might be a better way to put it. And then we need the standard deviation. Now, as we've talked about, the standard deviation, when you take a sample, it is not sigma. The standard deviation is sigma x bar. And sigma x bar, and I should go back and say that because what we're testing a claim about the population mean mu, and we're going to use the sample mean x bar. So therefore, everything in this problem is really about x bar. So when we talk about what's the standard deviation, we want the standard deviation when we're talking about x bar, and that is sigma divided by the square root of n. So sigma is 206.81, and then rad n is rad 275. Got to pop that in a calculator. Give me one moment. So by the calculator, that's 12.4711. I always like to do everything to 4 decimal places. Okay. So now we can draw the picture of the situation. So remember, this is step 1, is write down your hypotheses and the givens. Step 2 is make sure you describe the distribution. Step 3 is to draw the picture. It's a normal distribution, so there you go. We've got Z and 0 in the middle. And then this problem is about X bar. Now, what's interesting is that this is not an actual, we don't have an actual mu, we have a claimed mu. So the claimed mu is we want to know, is it 1210 or is it, as the alternate hypothesis suggests, is it actually bigger? So if we take mu to be 1210, then we know that the X bar that we get is 1234.59. So we mark that off. And so what we can see is that we're given a data value. So again, remembering the calculations that we did before, we're going to have to, so that's the situation of the diagram. So in order to do this problem, we're going to have to go, as I like to say, up the ladder. So how do you go up the ladder? First, you calculate the z-score, then you calculate the area. And then that's step 4. Step 4 is do the calculations. So the calculations, z equals. So what does z equal? Z equals data value minus mean over standard deviation. So what's our data value? It came from the sample, and it's 1234.59. Subtract. What's the population mean? Well, the population mean, at least based on the claim that we're comparing with, is 1210. Divided by the standard deviation. What is the standard deviation in our situation? Our standard deviation is sigma for X bar, and that is 12.4711. And then once again, you got to pop this in the calculator. And that gives you 1.97. So you can do Z to as many decimal places as you like, but the typical thing is 2 places. Either way is fine. And then from this, we have to go and figure out what are the area values. And we talked a lot about that before using statistics. Okay, and I'll just finish out going through how this problem goes. So let's okay. Okay, so I got my stat disk, and we need to know what's going on with that z-score. So analysis, probability distribution, normal distribution. The z-value is 1.97. So click evaluate, and now we've got some numbers. So to the left is 0.9. So actually, sorry, before I do that, I should mention one thing. When you draw your picture, because the claim is a greater than claim, you shade to the right. Now, it may seem a little confusing because the claim says greater than 1210, but the way that we set this up is to mark off, is to put 1210 in the middle, then mark off 1234.59, and then when you shade to the right, you're shading to the right of that value. They may not seem to agree with the alternate hypothesis, but it is the way that we set things up. It's a little, the setup is a little different than the just doing the calculations as we did directly in chapter 5. And the reason is that we're trying to answer a slightly different question. This is a little different because in this case, the mu is not an actual mu that we know is a fact. It is a mu that we're claiming. And so because of that, it sort of changes slightly little bits of how things kind of look in the setup. But it does not change doing the calculations. So anyway, we have our z-score, and so we can now label our areas. So to the left was 0.975, if I round it, 0.56, and then to the right was 0.0244, rounding to 4 decimal places, which is usually what they ask for here. Okay, so now we have done all the calculations, and now step 5, make the conclusion. So the conclusion, which I'm actually going to type out because my handwriting has seen better days. Hey. All right. A little bit of a crash issue. Okay. So we are 0.9756 confident. And of course, 0.9756 can also be written as 97.56%. So we are that confident that HA is true, meaning that mu is greater than 1210. Okay. So now let's go back to what the actual question is asking. The actual question is asking, what can we conclude at a significance level of 0.06? So at significance 0.06, and remember, the way I like to think about this is that 0.06 significance is the same as asking for 0.94 confidence. So there are different ways to understand hypothesis testing. This is the way that I suggest because I think it makes the most sense. So 0.06 significance is the same as 0.94 confidence. Let me actually write it that way. So 0.06 significance is the same as 0.94 confidence. So then the question is, do we have that much? So do we have 0.94 confidence? Yes, because we had like 0.97. So clearly 0.97 confidence satisfies asking if we have 0.94 confidence. We say yes, reject HO, accept HA, conclude that mu is greater than 1210. So remember that the question is always asking, do you have enough confidence or evidence to reject HO and accept HA? And that's the philosophy or the approach behind hypothesis testing. So I emphasize looking at the confidence level. So we actually have about 0.97 confidence, and the question is asking us if we have 0.94 confidence. Another way to think about this is to talk about it in terms of the significance. So 9756, the area to the left is the confidence level. Alternately, we could say that we have 0.02, so the area to the right, or the area in the tail, 0.0244 is the p-value. So another way to do this problem is not to ask, is our confidence level high enough? But another way to do it is to say, is our p-value low enough? Because the way that we've fixed our terminology, confidence and p-value, or significance and confidence are opposite things. So higher confidence means a lower p-value, et cetera, et cetera. Okay. So I know you really asked specifically about calculating the z-score, but I wanted to go through every little bit step by step of an entire hypothesis test. So let me just put in that let me fill in that explanatory line. So because 9756 is greater than 0.94, which is the same as saying 0.0244 is less than 0.06. Then we say, yes, we reject HO and accept HA. So again, remember that we will reject HO and accept HA if our confidence is high enough, which is the same as saying if our p-value is low enough. Okay. So that's the whole business right there. Does that answer your question?
I don't know if it's like the same as my question, but you explained this, so that's fine.
Okay, so it answers your question plus?
Yeah, I guess so. I was just talking about the standardized test statistic.
Mm-hmm. Yeah, and like I said, I wanted to answer that part, and then I just decided I'd go ahead and finish the problem.
Okay, thank you.
Yeah. So one of the things that I mentioned in the lecture videos, which I want to emphasize again here, is that doing a hypothesis test question, if you just look at steps 2, 3, and 4, this is exactly that is exactly the stuff that we've done before in chapter, I forget if it was 5 or 6, chapter 5, I think. Setting it up with your mu in the middle, calculating, getting your z-score, getting your area. All of that stuff is exactly the same. What is different is the fact that we're not just doing that calculation, but we're interpreting it in the context of hypothesis testing. And that hypothesis testing is basically adding on, using that calculation, starting with step 1, and then at the end, adding on step 5. So I hope everyone understands that steps 2, 3, and 4 are things that we have worked on before, but the interpretation steps of 1 and 5, that's new for hypothesis testing.